2023, question number 1. A competitive firm can sell any output at price P is equal to 1. The production depends on capital alone and the production function is this. Is twice continuously differentiable, and basically this is what it is saying. F0 is 0, F dash is positive, F double dash is negative. So it's a concave production function. Limit k tends to 0, F dash k is infinity, and limit k tends to infinity, F dash is equal to 0. Okay, so that basically means that the production function looks something like this. Okay. Firm has positive capital stock K bar to start off with and can buy and sell capital at price R per unit of capital. If the firm is maximizing profit, then which of the following statement is not correct? So profit is equal to P is 1. Okay, because they already have K bar to start off with, so I have to spend only on K minus K bar amount of capital. Now, if I want to maximize my profit, F dash is equal to R. Now, F dash is nothing but MPK. If the marginal productivity of capital is equal to R, then the firm will neither buy nor sell any capital. If MPK is greater than R, then basically the firm will want to buy additional capital, because MPK, which is the productivity of capital, is greater than the rental rate. So MPK greater than R, I will buy additional capital. So this is also correct, hence not the answer. Similarly, MPK less than R will sell some of its capital. If K bar is large enough, profit maximizing, Y is equal to 0 and the profit is R K bar, this is incorrect, and hence this is what the answer is. Because of the fact that K bar large enough does not make any difference. What makes the difference is whether MPK is equal to R, less than R, or greater than R. That is what the profit maximizing condition is. Why is F double dash important? So that we get that pi double dash is equal to F double dash. Now it has to be negative in order for this to be a profit maximizing condition. So this is also important for the second order derivative test to hold. So answer is A.
IIT JAM 2023 question number 2. This is my fx and this is my gx. Let's make an attempt to graph it. So this fx, if you try to graph it, x less than equal to 1. So it passes through x, it passes through 2. Okay. And once this is 1, then it becomes 2x plus 1. 2x plus 1 will be steeper. Here the slope is absolute value 1. Here the slope is 2. So it's something like this and then this. So if I join any 2 points by a straight line, obviously you will notice that the line is lying above the curve. So this is a classic case of convex. Okay. Now let's take a look at this one for gx. Less than equal to 2 is 2x. So it's something like this. And then after at x is equal to 2. See, why am I joining this? Some of you are asking. Put x is equal to 1 here. This is 3. Put x is equal to 1 here. This is 3. So both the values are the same. So it is a continuous function. Similarly here, put x is equal to 2 here. This is 4. X is equal to 2 here. It's 4. So it is a continuous function. So first it is having a slope of 2. Then it will have a slope of 1. So here the slope is 2. Here the slope is 1. And if I join any 2 points on it, the line will lie below the curve. The line lying below the curve would mean that this curve is concave. So this is convex and this is concave. So the answer is A, which is what the majority of you marked. Perfect. Sahi jawab. Answer is A.
JAM 2023 question number 3. Let S be a feasible set of a linear programming problem P if the dual problem of P is unbounded. If the dual is unbounded, the primal is infeasible. And if the dual is infeasible, then the primal is unbounded. Infeasible basically means that I don't have a feasible region, so the solution cannot exist. If the solution cannot exist, this is what the answer is. S is empty. B. JAM 2023 question number 4. Which of the following is not correct? A concave function is necessarily a quasi-concave? Yes. Quasi-concave can be a quasi-convex. Quasi-concave can be a convex function. Quasi-concave is necessarily a concave function. That is not correct. So, you need to understand a few things. A concave will always be quasi-concave. Quasi-concave can be quasi-convex. Like for example, the function e to the power x. E to the power x looks like this. This is a convex function, it's a quasi-convex function, and it is a quasi-concave as well. So a function can be convex, quasi-convex and quasi-concave all together as well. Okay. So answer is A here. JAM 2023 question number 5. So we need to talk about whether these two are level curves of F and G. So now what is a level curve? A level curve is like an isoquant or an indifference curve where this value will give you different values of F, and it can be expressed in terms of x square plus y square in the first case and x square minus y square in the second case. So can I express this entire expression in terms of x square plus y square, taking x square plus y square as say A? Here let's take x square minus y square as say B. Okay, so let's put this in terms of A. This is root over A minus A plus 2. So this entire expression can be taken in terms of A, and different values of A will give us different values of F. Okay, there is no other x or y component in F. So now this F becomes a function of A, and no x and no y is a part of it. Similarly, can G be made in terms of B? Let's see. E to the power y square minus x square plus x square minus y square whole square minus 2. So this can be written as e to the power of minus b plus b minus 2. So G can also be expressed in terms of only B, and F can also be expressed only
in terms of these values can be expressed as a level curve. So both S1 and S2 will be the answer.
2023 question 6. Which of the following is not a component of GDP? So we know that in national income accounting, transfer payments is never included. So the answer is C. 2023 question 7. Which of the following are direct instruments exercised by the RBI to control the money supply? So CRR, SLR, open market operations is. Foreign exchange rate is not really directly exercised by RBI to control money supply. So 1, 2 and 4, which is B.
3 question number 8. Which of the following committees? So this is a GK question. Use of implicit prices derived from quantity and value data collected in household consumer expenditure surveys for computing and updating the poverty lines, mixed reference period in estimating poverty lines. All this was given to us by the SD Tendulkar committee. What about the other committees? The YK Alag and the Lakdawala committee were also in estimating the poverty lines, but it was doing so in terms of nutritional values. You may choose to read about them on Google. The Rangarajan committee also dealt with poverty in the way that it considered a family poor if they are unable to save after making all the expenditures. Okay, this Alag committee was on the nutritional values in some other method, and the Lakdawala committee came into the nutritional values in terms of the amount of calories that each household is intaking. Okay. The Tendulkar committee dealt with what was in the question. JAM 2023, question number 9. Which of the following 5-year plans focused on rapid industrialization, heavy and basic industries, and advocated for a socialistic pattern of society as the goal of economic policy? It was very early on after independence, and the answer here is the second 5-year plan, 1956 to 61. The others went on the service industry. Okay. First 5-year plan was basically setting up the economy of India right after independence. Okay. This heavy and basic industries and rapid industrialization was the key over a socialistic pattern of society. It really advocated for that in the second year 5-year plan. That's B.
Question number 10, IIT JAM 23. Let M and N be events defined on the sample space. PM is 1/3, Pn complement is 1/4. So Pn is 3/4. Now, Pm plus Pn is greater than 1. तो M and N disjoint तो हो नहीं सकते हैं, because अगर वो disjoint है, then Pm union N is Pm plus Pn. How can a probability be greater than 1? Not possible. So not disjoint. It's B. Very easy.
JAM 2023, question number 11. Consider a two-agent two-exchange economy. The utility is max XY. The initial endowment of the good is 25.5 and 5.5. So the total endowment of X is 30 and that of Y is 10. Okay. So I get a contract curve which looks something like this. Okay. Now 25.5. This is the endowment point. This is the difference curve of the second individual, and these are the indifference curves of the first individual. Okay. Now, if this is the endowment point, second individual, this first individual, this is the highest indifference curve. This highest indifference curve of the first individual, second individual will be this one. So this is Pareto efficient. Similarly, this is also Pareto efficient. So it's either 30,0 for the first and 0,10 for the second, or 0,10 for the first and 30,0 for the second. Here, since I am at an endowment point which is here, this will basically go to a comparative equilibrium which will look like this: 30,0 and 0,10. Now, for what price will 25.5 go to 30,0? It will go to a price where Px by Py is equal to 1. This is going to be the competitive price. This is going to be the comparative price. So Px by Py is equal to 1. Px Py is equal to 2,2. Answer is B.
IIT JAM 2023, question number 12. A firm operating in a perfectly competitive market, which of the following statement is correct? So we need to talk about the profit function being homogeneous or not homogeneous in prices, and whether it is convex, concave in prices or not. Okay. Chalo, let's go on the whiteboard and solve it. Okay. So what is the profit equation? Profit equation looks like this: P into the production function minus WL minus RK, right? Now, profit maximizing condition is basically P multiplied by the MPL minus W is equal to 0. So basically, W is equal to P into the MPL, which is obviously a function of L and K. Can I say therefore that the condition is W is a function of P, and this LK will obviously come out to be something in W and R. This is what you'll get. Okay. Similarly, this is what you'll get at the optimal. So this is what we get for W and R. And we know that this is like this. So basically, profit equation can be written as P into FLK minus W is basically P into FL minus P into FK. This is not the perfect way to write it. The perfect way would be to write it in this particular fashion, that I have this equation, I have this equation, and then from these two equations you will get your L is a function of P, W and R. Your K will also be a function of P, W and R. And if L and K is a function of P, W and R, then FLK, which is my output, will also be a function of P, W and R. Okay, right? But you can think about the profit equation in this way, and hence you can see that I can take P as a common and you will get this. If in the profit equation I multiply my P by lambda, what I'll get is lambda into 1, lambda to the power 1, profit that was there earlier. Okay, what does this mean? It means that the profit function is homogeneous. Means that the profit function is homogeneous of degree 1 in prices. What I did was I took the profit maximizing condition, put it here, see that P is coming out to be common, and therefore we can easily see that the profit equation is homogeneous of degree 1. This is the first one. This is the first part. The second part entails a proof whether it is convex or concave, right? So in order to do the proof, let's see how to do it. In order to prove the convex part, let's consider P, P dash and P double dash. Now, if you recall the convexity definition that we did in functions, the convexity definition that we did in functions was something like this. Okay, and this is what we are going to use here. The line is above the curve. That is the convexity definition. Okay. Now, we consider three prices, P, P dash and P double dash. P would be the price. P would be the price for output Y. P dash would be for output Y dash. And P double dash price would have a profit maximizing output of Y double dash. Okay. And let P double dash be equal to lambda P plus 1 minus lambda P dash. So P double dash is nothing but a convex combination of the two. Okay. Now, profit maximizing at P double dash is basically equal to this. Right? This would be the profit maximizing condition. This would be the profit maximizing condition. Now, P double dash I already know. P double dash is what? Now, I know that for price P, profit maximizing output is Y. For price P, profit maximizing output is Y. For hence, P into Y double dash will give me a profit which is lower than P into Y. Similarly, P dash into Y double dash will give me a profit which is lower than P dash into Y dash. because P was the profit maximizing for Y. So the profit with P and Y will obviously be higher than the profit with P and Y double dash. And the profit with P dash highest would be with output Y dash. Therefore, we can write it down in this particular fashion that profit with P double dash lambda into this. I'm basically going into this format. Lambda P Y double dash plus 1 minus lambda P dash Y double dash. Profit with, the reason is, this is what, this is basically, I add these two. Okay. This is obviously less than equal to if I add these two. This is nothing but this particular equation, because this is nothing but the profit with P double dash. This is my P double dash. So the profit with P double dash is lower than the profit with P, the profit with P dash for outputs Y and Y dash. So this basically means that the curve is below the line when it comes to the profit maximizing condition. So what did I do? I basically started off with, this is more of a proof. Okay, I started with 3 different prices, took P double dash as the convex combination of P and P dash, where P double dash is this. And I wrote my P double dash in this way, that the profit maximizing output for P double dash is Y double dash, profit maximizing output for P dash is Y dash, for P it's Y. So obviously the profit maximizing combination of P dash into Y dash will obviously be greater than equal to P double dash Y dash. Similarly, P Y combination will give me a higher profit than P double dash Y. Okay, that is what I did here. P into Y double dash will give me a lower profit than P into Y multiplied by lambda. 1 minus lambda I multiplied on both the sides, with obviously lambda being a fraction or a convex combination. Okay, now this is nothing but the convex combination with P double dash, and this has to be less than equal to, because this was less than this, so this is less than this, and this part is less than this. These two basically constitute this profit function. So we can loud and clear say that the profit function is convex in prices. I have also put it up as a proof here. It's exactly the same thing that I've done. I've only explained it there.
2023 question number 13. A firm is operating in a perfectly competitive environment. A change in the market condition leads to an increase in the firm's profit by an amount K. So if the profit of the firm is increasing by amount of K, it means that the producer's surplus is increasing by the amount of K. Answer is A. The producer surplus is the same as profit. It's the same thing as profit.
IIT JAM 2023 question 14. Two people 1 and 2 are engaged in a joint project. Person 1 belonging to 1 or 2 puts an effort xi, which is either 0 and 1 or between 0 and 1, and it incurs the same amount of cost. So if it incurs effort half, the cost is half. The monetary outcome of the project is 4x1 x2, which is split equally between them. Considering the situation as a strategic game, the set of all Nash equilibria in pure strategy is. Now the interesting word is Nash equilibria, because Nash equilibria means a particular thing. It means the best response function of an individual to what the other individual is doing. So what's your best response? Let's look at the options. It says either a null set, which is nothing, or it's 0, 0, 1, 1, 0, 0, half, half, 1/4, 1/4, 3/4, 3/4, 1/1, 0011 half. So 0011 seems to be that it will be part of the answer. We have to check for half, 1/4 and 3/4, that are they Nash equilibrium or not. Let me check for half. So Nash equilibrium basically means that if the other person does something, what's your best response? So if the other person chooses half, what is my best response is what I'm going to see here. So let me make the profit of each individual. On outcome of the project is 4x1, x2. But since the returns are split equally, so each individual is going to get half of this, and the cost is xi, so each individual incurs his own cost. Okay. So let's say I'm looking at person 1. So for person 1, this is 2x1 x2 minus x1. Okay. Let's take x2 as given as half. 2x1 and x2 is half minus x1. So this becomes 2 gets cancelled, x1 minus x1, which is always 0. Right? So whatever be the outcome, choice of person 1, if x2 is half, person 1 is always having a 0 net profit. So he is indifferent between producing and not producing. Okay, so in that case, half and half is a possible answer, that they both produce half and they both will get a return of 0. So it is best response. Okay, it is giving them 0 outcome. All right, a 1-1 outcome is definitely better than a 0 outcome. But the thing is that in this, Nash equilibrium is not asking you what is the best outcome. It is asking you what is the best response. So the best response of half is half. Okay, so this is actually Nash equilibria along with 0, 0 and 1, 1. 0, 0 is everybody gets 0, and 1, 1 is basically 1, 1 is the best outcome. So it's going to be 2. Let's say x2 is choosing 1, so 2x1 minus x1, which is equal to x1. Okay, so you can maximize x1, which is 1, and you maximize x2, you get 1. So 1, 1 is the best outcome. But half is also Nash equilibria. It's not the best outcome, but it is Nash equilibria. Now let's see what about 1/4, 1/4. So 2. Let's say if x2 chooses 1/4. Okay. So this is going to be half x1 minus x1. So this is going to be minus half x1, which is negative. So the profit of x1 is negative if x2 chooses 1/4. So the best response of that is 0. So 1/4, 1/4 is not a suitable outcome. It is not Nash equilibria. So this outcome is eliminated. C is right. So A and B.
IIT JAM 2023, question number 15. Two firms X and Y are operating in a perfectly competitive market. The price elasticity of supply of X is 0.5. Price elasticity of supply of Y is 1.5. So supply elasticity will basically mean as the price is increasing, the quantity will increase. Market price increases 1%, X supplies less, not possible. It will supply more. Price increases by 0.5%, X will supply 0.25% because the supply is 0.5. Y experiences a rapid increase in marginal cost. Please try and understand that if my elasticity of supply is 1.5, it means that if my price is increasing by 10%, my quantity increases by 15% for Y. For Y, price increases by 10%, I am increasing my quantity by 15%. What does that mean? That means that if I'm increasing my quantity by more than proportion, if I'm increasing my quantity by more than proportion, it means that my cost is not increasing as much as the price. That is how I'm being able to increase my quantity even more than the price. The price increases by only 10%, but I'm increasing my quantity by 15%. That means that the marginal cost increase for Y is not as rapid. Okay. Whereas what happens in X? In X, if the price is increasing by 10%, the quantity increase is only 5%. So if the price increases by 10%, why is X increasing the quantity by only 5%? Because after 5%, it is exhausting the 10% price increase. Okay, so obviously the marginal cost increase for Y has to be lower than the marginal cost increase for X. If the marginal cost is increasing not at a rapid pace, I will be able to expand my quantity more faster, right? अगर मेरा marginal cost धीरे धीरे बढ़ रहा है, I can increase my quantity at a rapid pace. But if my marginal cost is increasing at a rapid pace, I will not be willing to increase my quantity by a lot. So that is what is happening. For X, the marginal cost is increasing at a rapid pace as compared to Y. Y, the marginal cost is increasing at a slower pace. That is why it is being able to expand more than firm X. Answer is B. Supply curve of Y is flatter. Supply curve of, if the elasticity of supply is higher, it means that the curve is flatter. It doesn't mean that the curve is steeper. Higher elasticity will mean flatter curve. More elasticity will mean a steeper curve. So that's also okay. Flatter curve, that means that the marginal cost is increasing at a lower pace because the supply curve is the marginal cost curve. You can think about it in that way. This is for Y and this is for X. Flatter means more elasticity, steeper means less elasticity.